explains the origins of some of these. For example, checklists, Churchman's social system design, etc. Are directly they directly originate from systems theory. Gaming, metagame, hypergame analysis, drama theory, etc. They are originating from game theory actually, but not mathematics, not with the mathematics or game theory, but just the informal terminology of games. SODA is from psychology. Total systems intervention, multi-methodology, etc. Try to explain how different methodologies can be mixed together and used at the same time in a problem situation which requires the support of different methodologies. Several of these have the common characteristics of having being developed through action research. Now, action research is important. It's a very important concept in sociology and in the social sciences. Action research is not, you know that we are all familiar with research. Huh? Research can take place in a laboratory, for example, or we can do research in our rooms, working on mathematical models. That's also research. Action research is different. When you do ordinary research, the results of your research can lead to some changes in the real world, to some action, okay? The research phase is separated from the action phase. But in action research, research takes place during action, okay? This is action research. The academician, the researcher, very famous person in research, Kurt Lewin, his name's over there. In the 1940s, he started this movement of action research, originated in the work of Kurt Lewin, who in the late 1940s recognized the problems inherent in the study of complex social and psychological processes by breaking them apart, by analysis and reductionism. He saw the problems in doing this and taking them into the laboratory. He advocated instead testing theory in action, in the process of implementation. So theory is tested during action in the real life, during the taking place of the real life phenomena itself. This is what is meant by action research. Action research contributes both to the practical concerns of people in a problem situation and also the objectives of science. So action research produces two types of results. Results that are immediately used to make improvements in the problem situation, and also results that enrich the sciences, social sciences. Okay, so that's action research. It's about all we need to know about action research. They all have one thing in common, these soft approaches. While hardware deals mainly with the content of the problem, içerikle ilgili hardware, giving only limited concern to process. Soft approaches put equal emphasis on both content and process. So the differentiation between content and process should be understood. Process is the process of inquiry itself. Huh? We said a few slides back, we said that people understood, beginning with Churchman in 1960, then Aikoff and others, they realized that propositions may not be accepted or may be rejected by the problem owners, by the stakeholders, if we don't pay attention to the process of producing those propositions. Process is the process, the action research itself, the process of the research, the inquiry itself. The content is what is in the inquiry, but the process is the actual inquiry. So in hardware, usually the entire emphasis is on content and not the process. Here, they should be equally taken care of. At the very start of an intervention, process is used for extracting content and underlying value systems. the probing of the issues, etc., at the beginning is all about process. When you answer all the what questions and then focus on the how questions, etc., then content will become important, perhaps. So think of a mathematical model. Trying to solve the mathematical model, that's what we mean by content. Think of the inquiry that you have to conduct before modeling about what the system is like, who are the stakeholders, what objectives are there, etc. The process of making those inquiries is called the process. Okay? Think of the third stage in hardware. The first stage was formulation. The second was modeling. The third was? What was the third stage in hardware? Implementation, right? Implementation is about process, for example. Modeling is about content. This is roughly how you can understand it easily, content and process. Okay. The objective in all these software approaches is to gain a shared understanding and mutual appreciations about values, interests, objectives, choices for action. We should bring people together so that they share their views about values. This is what we mean by the proposition should be culturally feasible. Culture is about values. Culture, how do you define culture? Culture is the set of values and norms of a group of people, of a society. Norms define how behavior is expected to be like. Davranış biçimleri, normlar. Values and norms are what we mean by culture. So interests, objectives, choices of action. Boundary choices, we have seen that boundary judgments are very important in OR. They are extremely important and subject to questioning in soft systems. The software approaches also recognize that a resolution of a problem does not necessarily require full convergence of views, of different views. A full convergence of different views is called a consensus. We should not expect a consensus to be achieved in problem situations normally. Consensus occurs only very, very rarely. People always talk about, for example, politicians talk about consensus. Bir konsensusa ulaştık falan derler. Don't believe that. Consensus never occurs very easily. People do not change their minds. They do not change their values. They do not change their objectives easily. They stick to them. But being a society, they have to act together somehow. If you wait for consensus to happen so that you can act together, you will be waiting a long time. It will not happen. So what are we going to do? The important concept is this next one, accommodation. So a full convergence of views and that a mutual appreciation of views may be sufficient. Even if I do not accept the values that you have or the objectives that you have in mind, I appreciate them. I understand why you own these values and objectives. This is mutual understanding. This is called an accommodation. It is like accepting to live together. In organizational terms, it is about, even though all our views do not match, do not converge, we can still take a decision for common action. Being able to take decision for common action, yani ortak hareket etme kararı alabiliyorsak, that is what we mean by accommodation. We accommodate each other's views, even if we do not agree with them. Accommodation. It's an acceptable compromise and commitment for common action. I should have underlined this last 4 words. This is the most important. Commitment or agreement for common action. For all organizations, for business organizations, for political organizations, for sports organizations, for families are social organizations, for clubs, anything, the important thing is being able to take a decision to act together. This is the most precious result of having an organization. This is why you have organizations. This is a struggle against entropy, to differentiate ourselves from our environment, to have an identity. And this identity can only survive if the members of the organization are able to take decisions to act together. So commitment for common action is all we need. Love is all we need. So commitment for action is very, very important. There's a Beatles song like that, if you don't know. Few users are familiar with more than one approach, or there are many approaches, as we said. Don't expect that, for example, some of our students have successful careers doing software in consultancy. Çok başarılı mezunlarımız var bu işleri yapan. They use these approaches as best as they can, but don't think that all those 20 or 15, 20 different methodologies are easy to master and use. Nobody can learn all of them and use them easily. These are difficult. There are several universities offering courses. There are workshops also offered professionally on these. But it's difficult. I mean, the consultant also needs to have good skills in interpersonal relations, in facilitating and negotiation. A different type of characteristic is needed for soft approaches. As an IE, you should not be only proficient in quantitative techniques and the mathematics of IE, but also in interpersonal relations, facilitating negotiation. These are different types of skills, and they are needed in these cases. Okay, so there are other comments you can read. I have made too many comments here. They are not really so important. Owning the solution is only a beginning. Planning for the actual process of change and monitoring the implementation has to go on. We have a diagram like this here which summarizes. Let's go through these. In contrast to hard operational research, this is not a sequence of systems whose outputs become the inputs into the next system. In hardware, we formulate, then we model, then we implement. We solve one problem which becomes an input, the output of which becomes an input to another problem, and there's a linear and sequential progression of problems, of steps, etc. in hardware. It's not like that here. System S is created or defined within system M. Note again how boundary judgments affects all aspects. As you can see, the structure diagram for problems structuring methods, this is from our textbook again, is like this. There is a system M. I don't know what M stands for, I forget. But inside that, there is in there a system S, narrow system of interest. So the narrow system of interest is the one we are already familiar with. If you were doing hardware, this is the one which you model using mathematics. This narrow system is the one which we model by using mathematical modeling. There are uncontrolled inputs, control inputs into the system S, and there are outputs, which are, one of them is a performance measure that we take up as a performance measure. But you can see that many other things are feeding into the narrow system from outside. What is feeding into it? Facilitation, problem structuring, technology, hardware, all the inputs are coming actually from the environment. There is an arrow going out of the inner system and going back into it, as you can see like that. That is called reflective learning. You learn from the system S that you model. Reflection means thinking about what you have learned. Reflection, tefekkür eski dilde. I don't know if you have a modern equivalent in Turkish, but tefekkür. You have to, reflection is an attribute, is an ability of humans. Humans are able to reflect. And reflection explicitly is important in soft systems thinking. So you can also, I assume that you have done so already, but if you haven't, please read the paper I uploaded, written by Checkland and Holwell. This is required reading, and I will for sure include questions on this reading in the midterm examination and maybe in the quizzes also. So please make sure that you read the article, Checkland's article, on the distinction between hard OR and soft OR. It's much better than my summary here. So, so that's that's lecture 8, and since we don't want to waste time, we have little time left in the semester, I will immediately start with lecture 9. As I said, lecture 9 and 10 is about soft systems methodology of Checkland. Now we are focusing on one methodology. Do you remember what we mean by methodology? You remember I told you in the very beginning, I gave you a vocabulary of the terms that we are going to use. We started with data, information, knowledge, understanding, explanation, theory. We also talked about truth and reality and method, tools, techniques, methods, methodology, epistemology. All those hierarchies are very important for you to understand. These are not important only for this course. These are for general knowledge. This is about the world. Methodology is different from method. Why is it different? Why don't we call this soft systems method, but soft systems methodology? What's the difference?
It's not only one method, but a set of methods.
If it were a method is like an algorithm. If it is a method, you know exactly what you are going to do next. A methodology is different. If you are using a methodology, you have to decide at each step what you are going to do next. Okay? It's not an algorithm. Is this clear? A methodology. So all these are methodologies. You cannot implement them linearly by going from one step to the other easily. Unfortunately, life is never easy. It is always up to you to make a decision. In a methodology, the implementation of a methodology requires at each step a decision of you to make. Okay, now Checkland, I told you the story of Checkland probably sometime. He was invited to Lancaster University to establish a department in the 1960s from a very successful management profession. He was a very famous manager in a large chemical corporation. And he was invited as a professor to Lancaster. He established a department called the Systems Engineering Department at Lancaster. Lancaster is a university which is very strong, and it's the #1 university in Europe in OR and in systems and things like this. In areas like in management also they are very strong, but especially in OR. So he established a systems engineering department at Lancaster, at which time they also established an operational research department. So these departments were separate from each other, and the difference was that in the OR department, it was all formal hard OR, quantitative techniques, etc. We have graduates, we have people in our department, professors who are graduates of Lancaster, including myself. But in the systems engineering department, they used an action research program all the time from the beginning. Systems engineering is another hard approach, but different from OR somehow. It's more engineering than operational research. And he established this department at Lancaster. He worked on a lot of applied projects because he made a point before accepting the professorship. He said that if I arrive at Lancaster, I shall do all research doing actual applied work. And they said, okay, that's why we are calling you. So he did that. And in all those projects he implemented at Lancaster through a company, the Lancaster University formed a commercial company which handled this sort of research. He applied systems engineering methodology, but gradually he started to be dissatisfied with the systems engineering methodology. He saw that it was not suitable for many of the real-world problems that they addressed, okay? And gradually he started to develop his own methodology. And he called it the soft systems methodology. Systems engineering is something like this. Engineers make sense of the world in the following way. A product or a complete system is carefully specified at the beginning. Systems engineering works like that. The specifications of a system or a piece of equipment or whatever is carefully specified at the beginning. Yani şartları açıklanıyor. The engineer then uses her professional skills to meet the specification in the most efficient, economic, and elegant way. So working backwards from the design that will be implemented, she works out, or he works out, the steps to implement so that that design will be realized in the end. So systems engineering works from the end backwards and goes forwards to arrive at the end. The engineer's thinking is teleological. She asks, what's the purpose to be served by the product, and works back from the purpose to create the product that will achieve that purpose. This is roughly what we mean by the methodology of systems engineering. It was formulated like this in America. It's not very popular now. Huh? You don't find systems engineering departments. There is one in Yeditepe Üniversitesi. One of our graduates is working there. There are a few in America, but systems engineering is more or less extinct by now. There's a parallel called, in the Rand Corporation, what they have called systems analysis. Of course, we use the term systems analysis many times in our everyday language as IEs, but what we mean by systems analysis is different from what they mean here. This is a methodology, systems analysis. This works by formulating or by focusing on a small number of alternative designs, 2, 3, 4 different designs, and investigate each one of them and choose the best one. This is what we mean by. For example, in your term project, in the transportation problem, you may, for example, make a list of 3 or 4 alternatives. You remember did you start working on the term project? If you haven't started, you'll be in trouble. Huh? It's not very easy. You have to. Okay. Now, there are a number of tankers available. There's a demand to be met. There are some problems. Maybe, for example, you can say that, let me define an alternative in which I buy one tanker of this type and try to work out a routing and delivery schedule. And then you can define another alternative by buying maybe 2 tankers. I don't know. I'm not trying to tell you what you are going to do. I'm just trying to give you an example of systems analysis. And by comparing these few alternatives, you may try to select the best. That would be called systems analysis, although it is hardware. But this is the way systems analysis works. Operational research, originally, we know this, sought to apply empirical methods of natural science to the problem of to real-world problems. Its models reflect, this is quite important, this logic of situations. This is explained very well in the reading, in the Checkland reading that you should have read by now, the logic of situations. Well, all these are for finding a search for an efficient means. These are all addressing which question? The how question, means, finding the best means. So they reflected hard systems. And Checkland started to develop the SSM when he saw that these were not sufficient because facts and the logic of the situation never supply a complete description of a human problem situation. So SSM was developed by working over hundreds of projects as a learning system. The SSM is a learning system. It's not a system which solves problems. Briefly, what is it? In this introduction chapter, I'm going to finish it today. We are just going to see roughly what SSM looks like. In the next lecture, we shall go into the details. And then we have a case example. I hope I will be able to complete all of these. Briefly, it's an organized but flexible process. When I say organized but flexible, what should you understand? If it were organized, it would be what? It would be a method. If it were fully organized, it would be a method. Since it is flexible, it is a methodology. Okay? It's not completely unorganized, but it is flexible. It's a process. It's a methodology, not a method. That deals with situations someone sees as problematic. Again, you understand the difference between a problem and a problematic. Problematic. If somebody sees a situation as problematic, it means that this somebody has not identified any problems, but he is unhappy about the situation. A situation, if it is problematic, it makes you unhappy and you look for a change, but you don't know exactly what to change. You have not been able to identify any problems. Okay? Probably you will not be able to identify any distinct problems at all. You will have to deal with the problematics all the time, sometimes. If you are able to address and identify a problem, then you can perhaps address it using hardware. That call for action to improve. If it is a problematic situation, you are unhappy about it, and you are trying to produce some sort of improvement so as to make these situations more acceptable. Notice that we are not talking about any optimization or an optimal solution. We are just trying to make an unacceptable situation more acceptable, which is less full of tensions and unanswered questions. A problematic situation is full of unanswered questions. We are going to try to impute and to put on some formalism and some order to the situation and reduce the number of unanswered questions. It's a process of thinking your way to taking sensible action to improve the situation. Thinking your way, it's about thinking so that you can take sensible action which will improve the situation. While you do this, you use systems ideas. This is roughly what SSM is. Now, to understand it better, we shall make more metaphors. The everyday life that we experience is a complex flux of events, ideas, actions, emotions. Do you remember I mentioned this at the very beginning of the course, in the first lecture, probably the introduction of the second lecture. The flux means current, flowing, of ideas, actions, emotions, events, etc. This is what we mean by everyday life. In everyday life, events happen, ideas pass through our minds, Ideas pass through many people's minds and they end up in actions, emotions, etc., to which we attribute a meaning. Every person, when views everyday life, attributes some meaning to that life. That's what all humans do. Humans are meaning attributing creatures. Okay, maybe animals also attribute meaning, but we don't know. That turns part of that flux into a situation. So that flux, when we ascribe a meaning to that flux, becomes a situation for us, which we may start to be seeing it as problematic. That situation may be seen as problematic and therefore needs intervention. Yani müdahale gerektiriyor. Interaction with a situation means that we make judgments about it that depends on our Weltanschauung. When we interact with a situation, you understand the hierarchy now. Huh? There's the flux of life. You attribute a meaning to that flux. Hierarchically now we are coming down. And we create a problem situation. We perceive a problem situation. And probably we perceive that something has to be done about the situation because we are not, it's problematic. We are not totally happy with it. So we have to intervene in the problem situation. So this sort of interaction is made by the judgments that we make on the problem situation, and these judgments depend on our Weltanschauungen. Here is a diagram of Czechland, which illustrates this. I like these diagrams very much. You see there at the top the flux. It's in a double helix. Events, ideas, etc. are intertwined and they are flowing in time, the flux of everyday life. There are also not only events and ideas, there are other things like actions, emotions, etc. This yields the ellipse there. This is a perceived problematic situation. By ascribing a meaning to that flux, we arrive at number 2. Will be perceived differently by people with different worldviews. So number 1. And at number 2, we make the note that this perceived problematical situation will be perceived in different ways by people with different worldviews. So it depends on our Weltanschauung. This perceived problematical situation will contain people trying to act purposefully. So we arrive at number 4. Make models of purposeful activity as perceived by different worldviews. Now this picture is a picture of SSM. It tries to describe to us how SSM is going to work. Okay? Different people will perceive this problem situation differently. They are acting purposefully. They have different ideas. So in step number 4 of the process, we try to make models. In SSM, we use models, but these are not the mathematical models that we are used to. These are called purposeful activity models. We make models of how people's perceptions are about the problematical situation. Then, using these models in this number 5 as a source of questions to ask of the problematical situation, therefore structuring a discussion about the changes which are to be made. We use these models as a basis for discussion between different stakeholders, desirable and feasible propositions, systemically desirable, culturally feasible, although it doesn't say that here. Oh, it says culturally feasible and desirable. In number 6, we find versions of the to-be change situation which different worldviews could live with. This is the accommodation step. They can live with. Yani ben bununla yaşayabilirim demek. Although I don't completely agree with what you're proposing. I can live with your proposition. That's what we mean by accommodation. And then implement the action. So this is a rough idea of SSM works, but we are not going to use this very much. This was the original way SSM was formulated by Checkland. Throughout the years of application of SSM, it was used hundreds and hundreds of times all over the world. SSM is very widely used in many, many very, very important and serious projects. It was used. So during this time, it was developed and it has evolved. Instead of these 7 steps, this is called the original 7-step SSM. This has changed a lot. We are going to study in the next chapter only the latest version, which is currently used. It's a 4-step version rather than 7 steps. So this is just historically the first description of SSM. We said over here that it is, where is it? I don't remember. I forgot. I've lost it. It's based on systems ideas. Now, how is it based on systems ideas? Systems ideas such as communications, control, hierarchy, emergence. Now, when we studied systems, we did not talk too much about communications and control. Our textbook, you should have read the corresponding chapter in the text, allocates some space for communication, control, feedback loops, closed loops, open loops, feed-forward loops, etc. I did not mention those in the lectures because really we do not build on those ideas too much in the remaining part of the course. But these are systems ideas are useful in SSM when we realize that the common characteristic of all problem situations is that they involve people acting purposefully. The purposeful action can be perceived as a system. This can be represented by a model. So we are going to construct models in SSM, which are models of purposeful action, okay? Purposeful activity models. These are models of what we think purposeful activity is. They are not models of what is taking place in the real world. This is very, very important, this last comment. In order to understand SSM properly, you should keep this in mind. We are not trying to model the real life. When we construct a purposeful activity model, it's a model of what we think the activity would be like. Okay? It's not what is actually taking place in the real world. You will see the difference as we progress. A purposeful activity model looks like this. It always comes in the shape of a diagram like this. There's a large circle, as you can see, in which there are 7 smaller entities. And outside this large circle, there are 3 other circles or shapes. Although this configuration will change from one application to the other, roughly, most purposeful activity models look like this configuration. The large part includes the operations. As you can see, there are 7 of them. There is a rule, 7 plus or minus 2. The number of these activities can be from 5 to 9. Of course, you can put in 10 or 11 also, but the usual number to stick to is 7. Because if you put in 13 or 14 or 15 activities, usually it means that you have to construct a different model for some of the activities, a separate model like this. 7, the number 7 is important in psychology also. For example, it says that psychologists tell us that you can keep not more than 7 ideas in your mind at a time. I don't know whether it is for this purpose, but each of these is an activity. That's very important. Each of the entities are operations. They all involve an activity. Then at the outside, we have a definition. we define measures of performance. These are the E's: efficiency, effectiveness, efficacy. There is a monitoring, there is a feedback. As you can see, the output of the operations is fed into the monitor. The output is observed. It is compared with the measures of performance. If they do not match together, we take action. This is exactly a feedback loop. We learn from our mistakes, and we make adjustments and go back into the operations to effect an improvement. Let me give you an example for this, and when we finish this, we can stop. This is a very primitive example, but useful. Suppose that you have a house, and you have a garden, and there's a fence around your garden. Bahçenin çiti var. And the paint has started falling off, and it looks old, and you would like to paint your fence to make it look nice and beautiful. A simple activity model for a system to paint the garden fence by hand painting. You have decided to paint your fence yourself because it will be cheaper, and you will take a brush and select a paint and paint it. If we would, this is an activity, isn't it? Painting the fence is an activity. So what would the purposeful activity model look like for this activity? This is the answer. This is the model. Let's start with the activities. Number one activity, decide the scope of the task, the importance and the resources. Okay? You have to decide about the resources you have. Is it important for me to paint the house, the fence, for example? You might say, well, let's wait another year. We'll do it next summer, etc. So you perform those actions. If you decide to paint it, in the second step, appraise the color scheme of the property. You have a house. There are other houses, neighboring houses. You look at the colors. And you have to appraise, you have to appreciate. This is an aesthetic problem here. What color are you going to paint? I mean, if you use a very stupid color, it may be worse than it was before. So you have to appraise the color scheme of the property, not only the fence, but the entire property. In number three, you decide the color to paint the fence. When you're doing this appraising, for example, maybe you have to ask your wife what color she wants. There are many things to consider here. In number four, you obtain paint. You need the paint, so you obtain paint. In number five, you obtain a brush. In number four, you prepare the fence for painting, whatever preparation may be needed. And then you apply the paint to the fence in number seven. So these are, as you can see, explicit actions. Each entity in your model represents an explicitly defined action. This is very, very important. The first one is an action also. It's an action of decision making. It could be a physical action. It could be a mental action. And the arrows, of course, indicate the precedences. I mean, action number 5, for example, you can begin it immediately. No arrow ends in action number 5, obtaining the brush. Doesn't have to wait for anything. But applying the paint to the fence has to wait for actions 4, 5, and 6, etc. Then you monitor the results. Of course, you have to define measures of performance. These measures of performance could be, for example, it should look nice. Your neighbors should be happy with it. Your wife will be happy about your choice, etc. If your wife doesn't like it, you take control action and you repaint your fence, etc. So this is a first example of an activity model. We are going to finish this very soon. The purposeful activity model for fence painting reflects the Weltanschauung of the fence painter. What is it? What's the Weltanschauung of the fence painter? The Weltanschauung. What is it? Yes, what is it? That's correct. The Weltanschauung is that if I paint my fence, my property will look nice, and it is good for it to look nice. This is the Weltanschauung. If he doesn't believe this, he won't do it. He won't paint the fence. Okay? That's what we mean by the Weltanschauung. There could be other similar models reflecting the Weltanschauung of the neighbors or the wife of the painter. This purposeful activity model we have seen reflects the Weltanschauung of the painter. You could construct other models of the same activity if his wife, for example, has a different Weltanschauung. Of course, in this example, it's not very easy to formulate different Weltanschauung. And probably his wife also would like her property to look nice and freshly painted. Probably they have the same Weltanschauung, so a single model is sufficient. But if people have different Weltanschauungen, maybe I mean, this is not a very good example for having alternative models. The point is that these models are not descriptions of the real world. Huh? These are models of one person's perception of the activity. They only express one way of looking at the problem situation and serve as intellectual devices of producing good questions to ask about the situation. Why do we construct these models? Because you see, forget about fence painting. If it were a really complex problem situation, there would be many different people perceiving the real world in different ways. So the action models would come not only one, in 2, 3, 4 different models. These models are going to be used as devices for producing good questions to ask. Not questions that you ask when you are sitting in a coffee shop. The formalism of soft systems is provided by modeling first. Değil mi? Kahvehane sohbetinde herkes birbiriyle tartışabilir görüş alışverişinde. Bunlar o unstructured. That's unstructured and not formal, and it's not useful. It's not effective. It's not easy to reach a useful conclusion which provides commitment for common action. The formalism that will facilitate commitment for common action is provided by this modeling. The models are used for producing, they are intellectual devices for producing useful questions. So that different Weltanschauungs are revealed and can be discussed. So these models will help other people to understand other people's Weltanschauungen and provide meaningful discussion with the purpose of achieving an accommodation that is systemically desirable and culturally feasible.